Yesterday we talked about radians. You guys are all pros at degrees. Radians is the new thing. Now, I mentioned yesterday why 360 degrees. Because somebody called dibs. That's pretty much what it boils down to. And then we discussed how bad 360 is. Because, you know, if you were 1 degree off course for quite a while, you would be severely off course. Okay? So just dividing that circle into 360 degrees isn't enough. And so it turns out that radians are true things based on the length of the radius of a circle wrapped around. And we found that it turned out that 2 pi radians went all the way around the circle. So instead of saying 360 degrees, now we can say that 1 rotation is 2 pi radians. Okay? What's nice about that is we can use it to convert. 1 revolution then is 2 pi radians. We also know that 1 revolution is 360 degrees. So these 2 things are equivalent mathematically. This can be reduced. We can divide by, what can we divide by?
2.
Yeah. Mm-hmm. So we can divide by 2, and it turns out that pi radians is equivalent to 180 degrees. So I'm going to do this a lot, ladies and gentlemen. I'm going to be like, where's pi? Okay, but you got to watch the hands because none of you are looking at me. Okay, watch me. Ready? Where's pi?
Right there.
Okay, 180 degrees. Okay, I know.
So is that what all these weird pi things are?
So where's pi? And you say 180. All right, 180 degrees.
Oh, okay. I didn't understand.
All right. That's how you remember stuff. 180 degrees. 180 degrees. Okay. All right. So again. So going back to why this is important. You guys trace your circle.
Here's one.
Trace your little lid. Trace your little lid. All right. Really important. So we're going to draw a little circle and draw in a diameter. Roughly pretty close there. Looks about right. Diameter. I'm also going to cut that diameter in about half if I can. Yeah. That's 4. There we go. So I am creating a circle. I've marked my center. I have a diameter. Very, very important. So if I'm drawing angles now, so I'm going to draw an angle. My initial side is running along the positive x-axis. So this would be an angle measuring 0 radians. And if I open that angle up and go all the way around, then how far have I traveled? 360 degrees or 2 pi radians, okay? So if all the way around is 2 pi radians, what would me be landing here be?
3 pi.
Oh, yes, both of you, actually. If I'm just opening here and opening up just this far, what would that be? Pi radians, which is equivalent to 180 degrees. Are you with me so far? Okay. All right. So 1 pi radians lands right here at 180 degrees. So this is why radians is actually better than degrees, because I can take pi at 180 and I can divide it into however many pieces I want. So if I take pi radians, I can say, hey, let's look at what's pi over 2. Well, if I take pi and split that semicircle into 2 equal pieces, then right here, yeah, pi over 2 is 90-degree angle. Yeah, so this is pi over 2. Well, the rule of thumb in our trig class here is that if we're going to take pi and split it into 2 equal pieces, then whatever I do to the top, I'm also going to do to the bottom. So I'm also going to take this bottom and split it into 2 equal pieces. Because then I can count all kinds of angles. So the nice thing is we can create fractions forever. And so if this is 1 pi over 2, opening up 1 pi over 2, this would be 2 pi's over 2, which reduces to pi. And then if I keep counting around, this would be 3 pi's over 2. And then all the way around would be 4 pi's over 2, which reduces to 2 pi. Okay? Does that make sense to you? Okay, kind of amazing, right? So not only can we cut pi into 2 pieces, we can cut pi into all kinds of pieces. So I could say, hey, let's cut pi into 4 equal portions. So again, I'm going to go back here to pi. Where's pi?
There.
180. 180, all right. And now I'm going to cut pi into 4 equal pieces. Well, to do that, first I'd split it into 1 wedge, 2 wedges. What do I have to do to get 4 wedges? Divide each of those. Oh, so now look at how many wedges are on top? 4. And whatever we do to the top, we want to do to the bottom. And so I create how many wedges all the way around? 8 wedges all the way around. All right. And so then, not only is it just 1 pi over 4, but we can keep counting all the way around. So here is the angle 1 pi over 4. But if I go here, what's this? 2 pi's over 4, which reduces to pi over 2. 2 pi over 4, what's this?
3 pi over
3 pi's over 4, what's this? 4 pi's over 4, what's here?
5 pi over
5 pi's over 4. This? 6 pi's over 4. Here? 7 pi's over 4. And what's this? 8 pi's over 4. Not 12.
I'm so lost.
All we're doing is cutting up pieces of pie.
Yeah.
All right? I know, right? Okay. So we can do this all day and night. I can take pie and cut it into any size wedge I want, which is better than degrees. Because in degrees, we just took 180 degrees and split it up into 180 pieces, okay? Where here, I can take pi, I can divide it in halves, I can divide it into 4 pieces, I could divide it into 8 or 12 or 37 or 2 million if I wanted to. That'd be hard to draw, okay? So, but the idea here is that as we go around, everything sort of cleans itself up. Kind of nice, okay? So we're going to practice drawing these angles. And I call it circles and dots, okay, because you see the dots on the circle, all right? All right, so we're going to practice drawing some more of these angles. So here we go. Example 1. We will use circles for this. Yes, we'll use those circles. Example 1, draw the angle in standard position. Find the complement and supplement of each angle. Draw the angle in standard position. Find the complement and supplement of each angle. I don't think you guys are going to get extra credit.
I don't think.
I don't think so. No. We're gonna run out of time.
Maybe these both in the same circle.
Okay, I wouldn't. I would. All right, so here, what's this symbol?
Radian, or no, that's it.
Theta, theta, theta. And it represents an angle measure. I'm going to use a couple of colors, ladies and gentlemen, and if you would like also to use a couple of colors, I'm going to use black and red and blue. And I would recommend getting a couple of colors. There's lots of colors on the round table in the back.
Ooh. Grab us some colors.
I like colors.
All right. Okay. So here we want to draw angle theta that is 3 pi's over 8 in size. So in order to do this, I'm going to start with pi. Ladies and gentlemen, where's pi? 180 degrees, all right? Over here is 0.
No.
Pi is right here at 180 degrees, okay? So first thing we do. Now, ladies and gentlemen, how many pieces do we need to divide pi into? 8. That's what it says. Divide it into 8 parts. So we're going to take that pi semicircle and divide it into 8 little pieces. So first, how many pieces did I divide it into now? 2 pieces. So then I'm going to go divide those. Now how many wedges do I have? 4. How do I get 8?
Let's do this.
To do it again. Divide those in half.
Wait, so only the top.
Only the top. Because that's pi. Pi represents just 180 degrees. So we're taking the 180 and dividing it by 8. Splitting it into 8 parts. Okay? Now the rule is whatever we do on top, we duplicate on bottom. So how many wedges get you all the way around? 16.
This is.
So you got to count the spaces. There's 1 space here, 2 spaces. Yeah, count the spaces, not the dots. Yeah. All right. So if I'm going to draw this angle, I have all of these little wedges. And what you need to understand is I haven't drawn them all in. But each wedge is the same size. How big is each little wedge?
Like 1 Costco pizza slice.
It's pi divided by 8. So each little wedge is pi over 8. They're all the same size, and there's a bunch of them. Okay. I need how many of these? 3. So this first one is 1 pi over 8. What's this one? 2 pi's over 8. What's this one? 3 pi's over 8. Oh, no, but they're fine. Don't worry. They're fine. All right, so here, I didn't draw the lines.
Yeah, just copy this.
All right, here is my angle that is size 3 pi's over 8. Okay, that's angle theta. So right here is angle theta, which is 3 pi's over 8. Okay. Because there's 3 little wedges that are sized pi over 8. 1 pi over 8, 2 pi's over 8, 3 pi's over 8. All right. Yes. All right.
We're all
Okay, very, very good.
Oh, yes. Yes.
Now we have to actually answer the questions here. We want to find first the complement. What does it mean to be a complement? Angle that adds to 90. Okay, so to complete that 90 degree. Well, where's the 90 degree angle?
4.
Right, yeah, right here, right? So we want to know, well, this piece, doesn't this little angle right in here make it up to the 90 degrees? How big is that?
I am
4.
It's 1 pi over 8 size, right? Every wedge is the same size, right? They're all pi over 8? Okay. 1 pi over 8. The complement is just 1 pi over 8. What does it mean to be the supplement?
180.
To get to 180. So we're here at 3 pi over 8. I want to know what angle gets us all the way to the 180 or pi mark.
5.
4.
5.
5.
Yeah, so 5 pi's over 8. There's 1 pi over 8. 2 pi's over 8. 1, 2, 3, 4, 5.
Oh.
Supplementing
I was like, we already.
5 pi's over 8. Okay? I know this is weird, but you'll get really good at this. To get from the supplement, so going from my 3 pi over 8 and making my way all the way to the 180 or pi. Okay? Yes, we're using 3 pi over 8, the starting angle. Yes. Okay. Good. Okay. Now, do you have any questions on this first one? No? Okay. So now I'm going to look at letter B here. So my angle right now, my initial side is on the positive x-axis here. And what I need to do is I need to look at first, where's pi? 180. 180 degrees is pi radians. What are we cutting pi into? No.
I mean, I didn't look.
10. You're taking pi and you're dividing it into 10 pieces. That's what division means. Cut it into 10 equal parts. So first, I'm going to cut it into 2 equal parts. What do I need to do then? Cut those into what? Whoa, can we cut it in half? Is that going to work? So this one got an eyeball. I'm going to put 4 dots. Oops, I missed. It's going to be a little hard when they're not even numbers, but we can manage. It's just estimating anyway. So let's see. 1, 2, 3, 4, 5. So this is the whole lines and spaces conundrum. It's always complicated. Okay. So over here, I'm going to put 4 dots as well. 1, 2, 3, 4, 5. Not. I'm a little smushed, but that's okay. So you got to have, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces all the way around.
So 18 degrees. Wait. Okay, wait. What I'm hearing is 18 degrees.
All right. How big is each little wedge here?
1/10. 1 pi over 10.
Yeah, 1/10 pi or pi over 10. Each little wedge is the same size. And how many wedges are on top? How many wedges get us all the way over here? 10 wedges. And we'd have to do the same thing on the bottom, right? Okay. I'm going to go ahead and do that just for practice. So 1, 2, 3, 4, 5. 1, 1, 2, 3. Oh, that was much better on the bottom half of my circle. So if there's 10 wedges on top, how many wedges make a full circle? 20 wedges. Okay. It's important to think like that. All right, so I'm going to draw my angle now. How many of these pi's over 10 do I need? 7 pi's over 10. So I'm going to count 1, 2, 3, 4, 5, 6, 7.
Me too.
There it is. This is 7 pi's over 10. That's our angle theta right there. Okay. Does this have a complement?
No.
No complement.
past
It's
90.
past 90. Very
Oh,
good.
yeah.
No complement. It's already beyond 90 degrees. No.
No negative.
No, no negative supplements and complements. We don't do that.
Yeah, that's me.
All right.
Upward.
So, ladies and gentlemen, then what is the supplement?
3 pi over
3 pi's over 10. Very good. 1, 2, 3 pi's over 10. The supplement is 3 pi's over 10. Okay. So there is our supplement. All right. Yeah, you getting that?
10.
Okay, we're going to do some more practice stuff.
On our homework, you mean?
Right now in notes. Okay, they're looking good.
No,
Oh, you're not done?
there's no
Okay,
space.
sorry. Go ahead.
I don't have space.
Yes, you're going to need more space.
Is it 3 pages?
This is- God, complain, whine.
No,
Okay,
it's
here we
just-
go. Last one. This is it, and then we're done. All right. Oh, I need my circle. All right. Again, I'm using a few colors here. So example 2 is find one positive and one negative coterminal angle for the given angle. So same thing, I'm going to start with circles, draw a diameter, mark the center, bless you. And I want you guys to go ahead and start by drawing the angle theta, 7 pi's over 6. Okay, I'm going to give you a chance to start that while I pause the video. All right, now we want to find one positive and one negative coterminal angle. I'm going to use red for the negative angle, so I'm going to start with the negative one. A negative angle just means go in the other direction, right? What does coterminal mean?
Same thing.
Same. It's like the same.
It's like the same angle. It starts, it has the same initial side, and it terminates at the same spot. But we just want to go in the other direction. So I want to go this direction. How big is that angle? 1, 2, 3, 4, 5. What? Pi's over 6 in the negative direction. That is our negative coterminal angle. That's it. Isn't this great? We're just cutting things into parts and counting. That's what it is.
Yeah.
Okay.
It's pretty good.
Yeah.
Yeah, not all of us graduated.
Okay.
I still don't know how to use the scissors.
Okay. Now we need one positive coterminal angle. So again, this is an angle that starts on the positive x-axis and it ends on the same terminal side, but now we have to go in the positive direction. Can I use 7 pi over 6? No. What do I have to do? Go all the way around and keep on counting. Ooh. How many all the way around?
Well,
12 pies over 6 plus the 7. Very good. So 12 pies over 6, 13, 14, 15, 16, 17, 18, 19. 19 pies over 6. 12 pies over 6 plus 7 pies over 6 more is 19 pies over 6. Okay? It's just counting. All right? All right, let's try another. All right, you guys can do the last one here. I think my video is probably just fine. So, we're going to start by taking pi, ladies and gentlemen. Where is pi?
180.
180. What are we cutting pi into? 2 parts. Just 2. Which means I'm going to do that on top. I've got 1 wedge, 2 wedge. This is the Amanda size slice of pie. All right. And then we're going to do the same thing on the bottom. All right. How many wedges all the way around?
4.
4 wedges all the way around. Very good. So this angle, though, our angle here is negative 3 pies over 2. So what do we need to do? Go clockwise. Yes. So if I'm counting here, this is negative pi over 2, negative 2 pi over 2, and what's this? Negative 3 pies over 2, straight up. All right. So there's our angle, negative 3 pies over 2. That's our original angle. Now, I'm going to start. I'm going to do the positive coterminal angle, which again starts on the same initial side and ends on the same terminal side. So what is this angle? Just pi over 2 for the positive coterminal angle. And you'll notice they did not say 90 degrees. If they give us radians, we stay in radians. Okay, you will almost never use degrees, right? All right, one of them is the easy angle. The other one is a little more challenging. We need the negative coterminal angle. In the negative direction, I can't use negative 3 pi over 2, so I need 1 full rotation and then keep on counting. So how many, 1 full rotation is how many pies over 2? 4 pies over 2, 5, 6, 7. Negative 7 pies over 2 is the negative coterminal angle. This is all the math you need, ladies and gentlemen. You do not need to write little equations. It's literally counting. If you have a good picture, it's just counting. Trying to do the math, you're going to get messed up, okay? So, which is very not how the book teaches it, okay? But just counting and some logic. Yes, sir. All the circles are there. All right, there you go. I'm done. Do you have any questions? All right, get back. Backside that worksheet. Finish that worksheet, ladies and gentlemen.